Bonus video time. So exercise 15, this is on the 4.6 complex numbers lesson. Number C is a member of the Mandelbrot set. Oh, Mandelbrot set, remember that's determined by this equation here, that z sub n plus 1 is equal to z sub n squared plus c. C is the number you're trying to test to see if it's in the set, and c sub 0 is always equal to, not 1, 0, yeah. And you just keep iterating that. Answer goes back into the equation. Okay, so this number c is part of the Mandelbrot set if the absolute value of the imaginary number is less than 2 after every single iteration. If it ever gets bigger than 2, then it's going to explode, it's going to go to infinity. Okay, so we're going to determine whether the number c equals I over 2 as a member of the Mandelbrot set. So here, if you take a look at the picture, this guy put this picture together, it's pretty nice. You can actually see in the complex plane where these numbers are located. So what we looked at before was the positive number 1 was not, but negative 1 was, and that number is right about there. So we're going to try I over 2. So if I look at I over 2, if this is 1 right there, I over 2 should be like right here. It looks like it's part of the set. So let's see if we can confirm that. And we're going to cheat this just a wee bit by using the calculator. Okay, so it's going to speed this up just a bit. So let me write this stuff down again. So my z sub 0 is equal to 0. The c that I'm going to start with is I over 2. And I'm putting this all into this equation, z sub n plus 1 equals z sub n squared plus c. Okay, so I'm going to pull up the calculator in just a second, but let me show you or tell you what I'm going to do first. What we're going to do is we're going to store this 0 in the calculator as a, so I don't have to type it in. I know it seems like kind of a weird step, taking 0 and storing it as a, but it'll make sense in just a little bit. We're going to store the I over 2 in the calculator as c, like just the c value right there. So I'm going to type into the calculator this, a squared plus c, right? And that's going to give me a new value. Whatever this value is, I'm going to restore that value as a. And then I'm going to just repeat the process on that number over and over again. Before I take the next step, though, I always want to check the absolute value. I want to check to see the absolute value of this thing. My answer, let's see if it is, always less than 2. And the calculator can do all of this very, very quickly, because you can see whenever we start doing this by hand, it can get out of hand. Let's start doing it by hand anyway. So we know z sub 0 is equal to 0. Z sub 1 is 0 squared plus I over 2, which is just I over 2. All right, that's fair enough. If I were to take the absolute value of that, remember this is just up a half on the imaginary axis, so its absolute value is equal to a half, so it checks out. Okay, so z sub 2 then, I take the I over 2 and plug it in. I over 2 squared plus the original I over 2 and work this thing out. And this is what I'm saying, like you'd have to do this over and over again, so we're going to pull up the calculator, set it up so that it can help us do that. So the calculator is right here. Turn it on, and let's first set it up so that it works right. So you go to mode, and under the mode, you see real right there. You're going to scroll down, and right beside it says a plus bi. And that's what we were talking about, how imaginary numbers are supposed to be written in standard form. So hit enter on that. And then quit back, go back to the home screen. Quit, second, quit, quit. Okay. Now if you look on your keypad, can you locate the I? The I is right up above the decimal key. Okay, so it's in blue, so I'll have to hit second. So remember, the first thing that I wanted to do is store 0 in as A. So let's type in my A. Store is right above on. It says STO with a little arrow. Store alpha A. Okay, seems kind of dumb, but I'm going to do it anyway. Now I'm going to store that I over 2 as C. Okay, so I is going to be second decimal sign divided by 2, and let's store that thing as alpha C. Okay, so now let's just type in that Mandelbrot equation. In terms of A and C, it's going to be A squared, and you're going to see this is the last time I'll have to type this in, because I can just keep calling this back, plus alpha C, and hit enter. You can see I get the 0.5i, which is exactly what I got right over here. Let's go ahead and restore that as A again. Now I want to take the absolute value of that. I can do that in the calculator again. It's under the math menu. Scroll over to num for number. First one is ABS, absolute value. It doesn't matter if it's a complex number or not. It'll still take the absolute value of it. Type A inside of it and hit enter. You can see I get 0.5, exactly what we did by hand. Okay, rather than having to type this in again, I'm just going to go scroll back up here, get this equation by hitting enter again. Now the A value is not the original 0 that I typed in over here. It's the A value that I stored before, which is 0.5i. So whenever I hit enter, it's going to take that 0.5i and square it instead. And I get negative 0.25 plus 0.5i. Let's store that again as A. And then take the absolute value. Again, I don't want to have to keep typing that stuff in, so I'll just pull it back. Hit enter. 0.559. Definitely smaller than 2, so far we're in the clear. Okay. So let's try it again. Now, if you have an older calculator, the older operating system on this TI-84 calculator, instead of being able to scroll up, you'll have to hit second enter, until you get what you typed in before. Okay, again, so the A value that it's going to put in there now is negative 0.25 plus 0.5i. Hit enter. So there's my new value. Store it as A. There it is. Take the absolute value of that thing. So again, I can go second enter, second enter, second enter. There we go. If I wanted to, again, this is less than 2. And I can keep doing this over and over again. Let me just do it one more time. So I'm going to pull that back up. It's so much easier if you're able to do this using the arrow key. Enter. And if I were to just take the absolute value of that, absolute value of second answer, I can see that even this one's below 2. So I'm going to conclude that this number is a part of the Mandelbrot set. So let me write that down. So I'm going to say that I over 2 is an element of, or a member of, the Mandelbrot set. And as a member of the set, it gets colored black on the complex plane. So let me scroll backwards here. So it gets colored black, one of these little dots right in here. Now technically this stuff outside here shouldn't be black. It should be probably white or some other color. I think whoever made this picture just wanted it to be very dramatic. Now, if I had done this and I get a number that's bigger than 2 at any point, then I would conclude that it was not in the set, and instead of coloring it black, I would color it some other color. Now, if you watch the Mandelbrot zoom, you see a whole bunch of different colors. And the other colors are coming from how long it takes for it to go towards infinity, that kind of thing. So it might assign it, say, red if it goes if it takes a certain number of steps to escape the number 2, or it might be the color blue if it takes a certain number of more steps to escape the number 2. Okay? All right, so that takes care of the Mandelbrot set as an application of just about everything we did in 4-6 using complex numbers. All right, see you next time.